Okay, yeah. Oh, sorry.
So I'm
Mhm.
doing this problem on Lava Science,
Yes.
and I did the math for it,
Hmm.
and I put that the answer was one, and it was
Hmm.
wrong.
Okay, give me a second. It is the exercises in the homework
Mm-hmm.
16, right? The determine check digit of the ABS current type with identification number 381. Yeah, E6. So, okay, let me check that. Honestly, I also didn't remember the ABS case. So, here, current type is here. Yeah, the last check digit is identification number mode 7. So what you need to do in this case, you need to do just taking mode of the 38186. So, okay, so let's check. So 31, 338, right? 36, so 1. Ah, I think that actually these are all the given number.
Mm-hmm.
And you need to find the last digit, which
Okay,
is
so
not
I need
given.
to put the 7 in,
Yes,
and then
here.
whatever I get from that is the
Yes,
percentage.
I think so.
Because I have the same problem.
Huh?
So, like, you have to include the end digit. So, for me, I didn't put the 7 in when I did the division, and so then
Wait.
that's why the number
But
is
we were taught to not put in the last digit.
Yeah, so, but
no. It's checking if that digit. So on the notes it says that is number 5 valid, and so you have to take the 500712 and then divide it by the 7 to figure out if that last number is valid.
so the given number is actually some digits without checking number.
Mm-hmm.
So you need to find the check
So
digit.
So in this
Yeah.
one, it doesn't give the check digit, but
Yeah.
in the question on the notes, it's asking if number 5 is valid.
Hmm.
so are you going to put
So I'm going to put a 7, and so it'll be 17, and so
Hmm.
37 times 2
So
is
maybe,
14, and so the check digit is not.
yeah,
oh
3.
you lost me. Sorry.
It
You lost me on that part. So my
education.
digit,
Hmm.
this is my digit,
Yes.
right? These are all the numbers.
Hmm.
It's that number divided by 8.
Hmm.
This is that last number I have.
Yeah. Hmm.
That is not my answer. Because I put
So,
that in and it told me no, just like that one.
yeah, so in this case, what you need to do is just put 8 on here.
Uh-huh.
Then
So
you have
78.
a 78, yes. Then you can do one more time, right?
So
So
I doing, oh, okay, wait.
then
So,
8 9 times 9 is 72. So when you finally get is 6.
so my answer should be 6.
Yeah, I think
So
so.
I'm supposed to actually use all the digits.
Yes, because in this case, the program is just find the check digit, not the determine whether given number is buried or not, right? So that's the difference, yeah.
Yeah, that's the one I got stuck on. And just to clarify, my
Mm-hmm.
issue is, have you seen the homework? Right, you made it.
Which homework do you mean?
The homework that is due Wednesday. Yeah, it's
To
due tomorrow.
tomorrow? Oh, sorry. I definitely extended because we didn't finish it, right?
We pushed it to like Sunday night
Yes. All right.
because I don't think we've gone over the material.
Yeah, I understand. So,
All I have left is 7 and 8 on the notes, and then I like we're not able to figure out the rest.
okay, so I will put those homework extension to, okay, give me a second. So first over 16 should be due date to this Sunday. Pardon? Mm-hmm.
Would that be the sum of the digits mode 9, or would that be number mode 7?
In the case of AB square, it is just number mode 7. But yeah.
But for the bank routing number,
Yeah.
there's one that's absolute digit for a bank routing number.
Mm-hmm.
So would that be the sum of the digits mode 9?
Yes, that's sum of digit mode 9. Yes. No problem. No problem. Yeah, I think that it's a little bit difficult to finish everything.
It's just not your luck today.
No, it's really not. Oh, yeah, see, I forgot to tell you, during my exam, I'm fine.
Mm-hmm.
I think my grade is okay.
Mhm.
But my Wi-Fi actually turned off during my exam
Oh,
for 10 minutes.
oh my gosh.
I still passed though. That's all.
Yeah. So I hope that you didn't any,
Yeah.
this.
I would not want to have taken it again.
Okay, got it. No problem.
I would not want to take it again.
Okay, got it. So yeah, in the next time, we're definitely on. Mhm. Mhm.
So I didn't lose my progress.
So did you check your exam too and see anything you didn't make on?
Well, I looked at everything before I hit submit.
Submitted, but
Yeah,
then you lost. Okay, got it. Yeah,
I did not lose any work.
great. Yeah,
But,
Yeah.
if that happens again, I'm going to email you.
you're right. Yeah, and also if you just saved it, then I can see that actually what kind of question you just saved but not submitted. Then usually in that case, I just grade based on your spot you saved, not the submission. So yeah, pre-saved it. Yeah, I mean, for this kind of thing. So yeah, I think that in the next time we will do not have such a things, because in the next time I'm planning to, yeah, because there are some students who are not comfortable with, WebAssign things. So, and in the next time we can use Anorak. And so I will plan to just give you PDF version of file. If you want, then you can serve it. No? Okay, yeah. So I will just read someone's, yeah, so I will just give you choice for which one you are comfortable. So if you want to just serve it in the WebAssign or Anorak, then you're okay, but you need to do, Mhm.
If you could also create, I know you, well, sorry.
Mhm.
You currently write an exam review.
Yeah,
On OneNote.
yeah,
And that's part of review.
yes.
Could you also
Uh-huh.
make that review
Uh-huh.
into a WebAssign review?
Ah,
So we can practice putting it into WebAssign and looking at what it would look like.
okay, yeah, that's possible.
It's 0 points.
Mhm.
It's just the review, but on WebAssign.
Okay, got it.
So that in the Zoom call,
Mhm.
we can go over
The WebAssign.
WebAssign.
Mhm.
And if we want to,
Mhm.
we can still look at your old notes.
Okay, got it.
Your review by hand.
Mhm. Okay, so yeah, I will make sure that in the next time I will update review on the WebAssign as a program first. Then I will also give you a solution for the review on WebAssign or on the eCampus.
More comfortable.
Mhm.
You can review
Yeah,
similar to the exam as possible.
you're right. And also I know that my writing is not that good, so yeah.
Just WebAssign,
Mhm.
type it.
Yeah. Okay, great. Yeah, no problem.
Another question.
Yeah.
So I did the sum of the digits for
Mhm.
all of these, and I got 27.
Mhm.
And then I divided by 9, and I got 3, and it says it's wrong.
Okay, let me check. So number 4, right? So give me a second. So yeah, maybe the numbers are randomly. So in case of routing number, yes. Oh, in case of routing number, did you do this calculation?
Oh, I didn't do that calculation.
Yes. So in case of the bank routing number, you need to,
But you use the 7A1 plus 3. Like, is that
Yeah.
a constant?
Yes.
The 7 and the 3.
Yes. Then you can divide it by 9. Yeah. Mm-hmm. Yeah, so I know that in the homework, they require you to just give some number and figure out whether it is buried or not, or figure out what the check digit is. But I promise that in the exam, I will give you all formula because I don't like to, I don't want you to memorize all the formulas. So when you solve your homework, then just refer lecture note and see what kind of formula you can use for that homework, then you can solve it, right? So yeah, don't worry about to memorize all the formulas in the program. Yeah. Okay. Okay, howdy. So I have few announcements, actually so many announcements. And number 0, I forgot to write down is that, yeah, you can claim for exam 2 until the Thursday night. Yeah. So if you have any question about your scores on exam 2, or if you have any.
Can you share your screen?
Ah, okay. Thank you, Madeline. I forgot to share in my screen. Oh, where is it? Okay. Can you see it or not? Okay, great. So, oh, sorry. Yeah, so if you have any question on your exam 2 score, you please let me know. And also, yeah, since it is a WebAssign thing, so maybe if you have some, some minor mistake, like you can just put the answer number A to put it in the number B, or such a, transpositioning your answers or such a thing may happen, then sometimes I usually just, see all your exams before, giving you scores, but maybe there are something I just miss it. So please check your exam by your own using your, my email about the grading scheme. And if you have any question, please let me know so that I can help you for giving you more partial credit or something. So that's the announcement 0. And so please do it until the Thursday night. So after Thursday night, I do not accept any claims on exam 2. So please do it before the Friday. And I just found that homework 16 and 17 due date is from tomorrow and next Thursday. So I will just extend it to the Sunday. So homework 16 due date will be on this coming Sunday night, and homework 17 will be due on next coming Sunday night, right? So don't worry about the due date of homework. And also in the homework 16, they just give you, problem, right? Here's some number. Can you figure out that this number is, valid or not without any giving you any, check digit scheme? But you can refer the lecture notes to solve such a problem in the WebAssign because all the examples are from the lecture note. And also in the exam 3, I promise that I will give you all the schemes. For example, I will give you just formula for how to find the check digit. Then I will let you do, solve the problems, right? So I do not like to, I do not want you to memorize all the formulas because, it's not that, productive for this course. So yes, don't worry about, memorizing formula. Just make sure that you can apply the formula in the lecture notes to, solve your problem or not, right? So that's the second thing. And the quiz will be in Thursday. And this quiz actually done by Honorac because I want to use Honorac on exam 3, but to do this, departmental guideline is that I need to do one quiz on the Honorac for making students be comfortable with using Honorac. So at this time, you can see your quiz on Thursday in the Honorac. So it will cover the, problems in the number 16. And also, and in the, in this exam 2, the average of exam 2 is lower than 70, and median of this exam is 70. But my focus is to, keep your average on 75. So if you got the full credit on this quiz, so this quiz is 5 out of 5, and if you got the full credit, then that 5 points is not in the quiz part, but it will be added on the exam 2 part. So For example, if you just got exam 2 as a full score, 100, and also if you got the quiz in the 5 points, then all you can get from exam 2 is 105 over 100, right? Okay, so please, serve those quiz on the Thursday. And will the quiz be over chapter 16? Yes. Yeah, quiz will be over from the chapter 16 containing the 2 days lecture. And is the quiz not open notes since it is on Honora? Yes, but in this time, I will give you, I will give you just formula sheets so that you don't need to, memorize the formula, right? So I'm pretty sure I didn't made it right now, but I'm pretty sure that the quiz looks like so. Here is some formulas that you can make a check digit for special schemes, and we have some numbers. So can you check it whether this given number is valid, or what is the check digit for given number, or something like that. So I think that if you understand all the things we did in the last time and today, then I think you don't need to use notes, right? Because all formulas are on the quiz. Okay. Do you have any question? Good. And as I said in the number 3, or why the reason why we need Honora on quiz is I just want to adopt the exam 3. And from this exam 2, I have some feedbacks from the students that maybe some students are comfortable with just using paper or PDF. So some students are not comfortable with just writing down on the web assignment. So I understand, that is reasonable. So in the exam 3, I will give you 3 choices for taking exam. The first choice is web assignment. So it is just as usual as we did in this exam 2. So as like the exam 2, you can just log into web assignment with Zoom proctoring. Then you can just do your exam, and after doing this, just type finish it and taking your pictures and send it to my email. Then you are done. So it is just same as exam 1 and 2. So you can choose one option in here. And the next option is you can use Honora, right? In eCampus. But unfortunately, I cannot give you, time frame window because department is worried about the possible, academic dishonesty. So in this case, you don't need to log into Zoom proctoring, but you need to serve your program at the same time when in the exam time, right? So, but in this case, you don't need to log into the Zoom proctoring. Just log into eCampus and follow the instruction from Honora. Then you can serve it like use your programs in the WebAssign, because eCampus and WebAssign are very similar. So you can choose second option if you want. And the third option is, if you think that WebAssign is not comfortable for you, then I will just provide you PDF version of the exam. So in this case, in this case, maybe you need to log in a little bit earlier than usual, but at that time, so in the given time, you can just print your exams and write down all the things in your PDF, in your papers. Then just after finishing it, you can just take in picture and send it to me and rip up your papers and done. So it is just same procedure as we did in the WebAssign, except that you need to print the PDF version and writing down on the paper. So if you're comfortable with this way, then please let me know. But also in this number 6 case, you also need to log into Zoom for proctoring, right? So so there are 3 options here. And the last one is about the review. And I have some feedbacks that, my review as your handwriting is not that good for you to review. So, and the next time in exam 3 and 4, I will just make, review on WebAssign so that you can just type your review questions on the WebAssign as like what you did on the exams. And in the review session, I will just serve with you on the Zoom using WebAssign, right? So it means that I will do not give you, handwritten version, but also solution will be given in the WebAssign. Not WebAssign, sorry. It is in eCampus. So yeah, in case of if I made a WebAssign review questions, then yeah, also answers are also in the WebAssign questions. So maybe you can just figure it out much easier, right? Okay, so there are a lot of announcements, but I hope that this helps you to get the good scores. So do you have any question on exam or homework or anything else on the course? Pardon? Oh, yes, so that's a good question because at this point, the exam day is not too longer than here. So it will be November 3rd. So it is just 2 weeks after right now. But don't worry about that because it is. I know that it is. Yeah, there are too much exams. But in the exam 3, each portion for total average is just 15%, right? For all other exams like exam 1 and exam 2 and exam 4, they take 20% of the total average of your score. But in this exam 3, it will only takes the 15%. So yeah, so I think that if you are just be familiar with this number 16, chapter 16 and chapter 17, and you don't have not much problem to solve it, right? Okay.
So exam 4, that grade will replace our lowest grade higher?
No. No, yes, no. So exam 4 do not replace any lowest grade of exam because it is not a comprehensive test. So that's the reason. Yeah. In the syllabus, I reduced it at that point, and I also, actually that's the thing I made a, take it back statement in the start of the semester. Yeah. So yeah. Okay, do you have any other question? Great, then let's start with the 16. So I just wanna review the last example because there are some students who are not familiar with this scheme. And so what we did in the last time is just checking that from the given number, whether the given number is valid or not, or if you have some missing number on your given number, then find the missing number so that we can find the, so that we can make the whole number is valid, right? So for example, in case of example 1.3, we know that this ID number consists of 3 digits, and first digit is just checking digit. And this checking digit is determined by this formula. And what we have is 57x6, but we don't know what x is. But we want to make that this whole number as a correct number, right? Then what we need to do is just put all the numbers in the formula. And since the problem says that the given check digit is correct, it means that this x makes this statement is correct, right? And if you just do all the calculation, and if you just simplify in the right hand side, then what you can get is that 6 should be equivalent to 3 plus x mod 7. So by putting x for 0 to 1 to 3, if you just put all the numbers on the x, then what you can get is that 3 plus x is equal to congruent with 6, if and only if x is 6, right? So that's how we solve the example, right? So in this example, what you need to remember is that the procedure is just if you have some missing number, then just put all the numbers on the formula, and then you can simplify in the right-hand side and left-hand side. Then by putting, by investigating each case of case by cases, you can figure out what is the missing number, right? So that's the scheme on example 1.3. And now today, we will do a little bit more than this. So instead of this, so for example, if our check digit is not the 6, but if it is 5, then in this case, actually we cannot determine our x in the example 1.3 because in this case, x can be 2 or 9, right? So in that case, yeah, we cannot recover our x. So this is called that the check digit doesn't catch the errors. And now what we want to do today is to figure out that when this check digit doesn't work, right? So there are two possible cases. So one is just, so there are two errors on identification number. So one is we just put some number, error number, we just put some different number in a digit. Error, or okay, put a long number in a different digit. And the second one is that transposition of two numbers. You can just, so transposition means that you can just change the numbers, right? To digits. So for example, in the first case is that if A1, A2, A3, A4 is the correct one, correct number, then put a wrong number means that you can just put E1, which is called error, instead of A1 and just write down all other numbers in the same position. Or you may have some error on position 2. So in that case, we can just call it E2. So these are the error. So that's possible cases. Or sometimes all the numbers are correct, but you can just put the wrong direction. So for example, you can just write down A2 first, then write down A1 and A3, A4, or you can write down A1, but put A3 and A2, A4, and so on. So maybe you can write down A4 first, A2, A3, A1, something like that, right? So these are two common errors in the identification number. And what you want to do today is that check whether given check digit can figure out that figure out this kind of error or not, right? So to deal with this, okay, so check digits are designed to catch errors, but unfortunately, some cases not all errors will be caught. So how do we determine which errors will not be caught is what we want to do today. And to do this, key idea is that for an error not to be caught, the correct number and the number with an error must produce the same check digit, right? So likewise, in case of this example 1.3, with 5 instead of 6, in that case, 2 and 9 actually generate the same check digits. So it usually, does not, it usually does not distinguish the error number and the correct number, right? So to do this, first of all, write a general form of the correct number and label the correct number with A1, A2 to A3 something where AI represents a single digit, right? So a digit is just number from 0 to 9, right? So it is just less than 10. And after that, write a general form of the incorrect number. So the case of A is just transposition error, which means that it is just, you just write down, this is the second case, what I mentioned in this one. So you can just rearrange the AIs according to the type of transposition. And for single digit error, you can just use EI to represent the error for the digit that you should have been AI. And then find the check digits for the correct number and incorrect number mode M using those characters. Then you can figure out that the error will not be caught if the check digits are the same mode M, right? Because so in case of the example 1.3, if 2 and 9 are same in the mode 7, so in that case, we cannot distinguish it, right? So use the fact that if X is equivalent to Y mod M, then X minus Y is multiple of M. Then you can determine the multiples that are integers between 1 and 9. So the error will not be caught when the absolute value of X minus Y takes on these values. So then you can figure out that when such a thing happens. So in case of 1.3, 2 and 9, you can happen it. And 1 and 8 also cannot be distinguished. And 0 and 7 are also not distinguishable. So in the case of 1.3, there are all three cases that happens, right? So I know that this is a little bit, difficult to follow by itself. So let's just deal with examples. So as I said earlier, in the math, actually, it is not important to remember such a procedure, but it is important to do by your hands to remember everything in the math, right? So it's like exercises, right? So suppose a 4-digit number. In this case, first digit is the check digit, and it is the sum of the first 3 digits, mod 9, right? So here, formula is that A4 is equal to A1 plus A2 plus A3 mod 9, right? So that's the formula for check digit. Determine if a single digit error in the first digit will be caught, right? And to deal with this, first of all, you can, as usual, you can write down A1 as your first digit. Yeah, A2 as a second digit. A3 is third digit. And A4 is the first digit. Then just put that you have some error on the first digit. So just write down E1 as just the number with error. Right? Then, so check digit for correct code is this one, right? So A4 is equal to A1 plus A2 plus A3 mod 9. But check digit for incorrect code is E1 plus A2 plus A3 mod 9, right? So say this is A4 prime. And the error will not be caught if those two numbers are same, right? So what you can do is that if these check digits are the same, i.e. if A1 plus this number and this number, mod 9 is the same, right? So that's how we get this formula that A1 plus A2 plus A3 is congruent to E1 plus A2 plus A3 mod 9. But this is the same as, the difference between them is a multiple of 9. But from here, you notice that A2 is just canceled out and A3 is canceled out. So this is just same as A1 minus E1 is a multiple of 9. Actually, that's what we have in here. And you can see that difference between A1 and -1 is multiple of 9, means that A1 minus E1 should be 9, right? Or it may be -9. And this will happen only when A1 is equal to 9, E1 is equal to 0, or A1 is equal to 0, or E1 is equal to 9, right? Okay, question? Oh, yes. So what happened in here is that I just simplified this equation, right? So from this equation, we know the remainder of this part is the same as the remainder of this one, right? So what I did is, okay, I will just do it much more slow. So here I just put negative A2, negative A3 for both sides to get A1 plus A2 plus A3 minus A2 minus A3 is congruent with E1 plus A2 plus A3 minus A2 minus A3 mod 9. Can you see that why this happened? So what I did is that, yeah, since it is also congruent equation, if you just take out the same number, then both sides are equal, right? So that's what I did. Then again, you notice that here, this is plus positive A2, but this is negative A2. And this is the positive A3, but this is negative A3. So they are just canceled out. Likewise, here, this is positive A2, but this is negative A2. And this is positive A2, and this is negative A2. So they are also canceled out. So what we wrap is that A1 is congruent with E1 mod 9. Does it make sense? So it means that remainder of A1 by dividing 9 is the same as remainder of E1 by dividing 9. So A1 minus E1 should have the multiple of the 9, right? Because they have the same remainder. So if you just taking difference, then it should be multiple of 9s because their remainders are just get rid of it, right? So that's why we can get A1 minus E1 is multiple of 9. And from here to get here is just, it is just a brute force, right? What I mean brute force is that you can just put some numbers, right? But in this case, A1 is also, is from 0 to 9. And also E1 is also from 0 to 9. So it's, if it is in the multiple of 9, then their difference should be inside of, A1 minus E1 should be inside of minus 9 to 9, right? Because they are difference, right? And E1 cannot be negative number. And here from minus 9 to 9, the OR mode 9 is when A1 is, so here minus 9, 0, 9, multiple of 9s, right? Sorry. But 0 cannot be here, right? 0 means that A1 and E1 is the same, right? But we assume that E1 is different with A1, so 0 cannot be here. So only thing we can make is when negative 9 or 9, right? But in case of negative 9, so yeah, if A1 is just 1, then even if E1 is 9, A1 minus E1 is negative 8, which is greater than negative 9. So we cannot make it, right? And if A1 is greater than 1, then definitely we cannot make negative 9 because, for example, A1 is 2. Then even if E1 is 9, A1 minus E1 is negative 7, which is greater than negative 9. And 9 is the biggest number which we can choose for E1. So in this case, it does not happen. So only cases we happen is when A1 is 0. And E1 is 9. So that's the case for when their difference is negative 9. And by the same reason, the 9 already happened when A1 is 9, E1 is 0. So here, integers multiples of 9 between 1 and 9 is 9. And why do we care about multiples that are 0? Because A1 is different with E1, right? Because E1 is the error number. And why do we not care about multiples that are larger than 9? Because difference of single digit are also single digit. Is also single digit. That's why we only care about the case negative 9 and 9, right? So does it make sense, or do you have any question? Good? Okay, great. Good. So this scheme cannot separate. Yeah, the error will not be caught if we use 0 instead of 9 in the first digit. Or 9 instead of 0, right? So in those two cases, check digit cannot distinguish error and the correct one, right? Okay, does it make sense? Or do you have any question? So the last part is that from this calculation, what we can conclude is that the error will not be caught if we use 0 as E1 instead of 9, which is A1, or if we use 9 as E1 instead of A1, which is just 0. So what it means that, so there are several cases of valid number, but there are two cases where your valid number in A1 is just 0. And when you type, the error number is 9. And the second case is when where your A1 is just 9, but your error is 0, right? So these are second cases. But in these two cases, so if you just type 9 mistakenly, which is actually 0, then this check digit A4 does not distinguish your error and your correct number, right? Also, in case of your original number is 9, but you mistakenly type 0 on the first digit, then also your check digit doesn't distinguish the error and the correct number. So that's the meaning that error will not be caught. Okay. Good. Good. Okay. Do you have any question? So honestly, what we want to do today is just we just repeat this procedure again and again for example so that we can be familiar with. So, okay. So, okay, could you repeat your question? Sorry.
So we have
Mhm.
our equation that's like A1, A2, A3, and we
Mhm.
have the other one that's B1, A2, A3.
Mhm. Mhm.
But then we also have our mod 9 value.
Mhm.
We want to put it on one side. Does it matter which side we put it on?
No, it doesn't matter. So all we matter is that actually they are the same, right? So we want to find it when they are the same by mod 9. So it doesn't matter about the size. Yes, you're right. So what Grace, right? So what Grace questions is that does it matter on which side the number has? So from here, when we have some error number, then maybe our check digit should be here with error code. And if we have just the correct number, then what we have check digit here. So yes, so what we want to find is that when those two check digits are the same, right? So in that sense, you don't need to distinguish when the cases by cases. So just find out, just make sure that make the equation as simplified. Then you can figure out which number gives you the same equation, right? Okay, great. Good question. Okay. Do you have any other question? Okay, then let's deal with one more example. So here we know that the check digit for 4-digit number are given by this formula and determine if this scheme will catch single digit errors in the second digit. So here our error occurs in the second digit. So in this case, incorrect code should be A1, E2, because our error happens in the second digit. So E2 is different with A2. And the other digits are correct, A3 and A4. So here, check digit for correct one is from given formula. It is 3A1 plus A2 plus 9A3 mod 4. And check digit for incorrect code is 3A1 plus E2 plus 9A3 mod 4. And the error will not be caught if the check digit is just same. So if this 3A1 plus A2 plus 9A3 mod 4 is, is congruent with 3A1 plus E2 plus 9A3 mod 4, right? Okay, question? The first one is also with mod 4. Yeah, but both are them with mod 4. Yeah. So what their difference is that the first one uses A2, but in the second one uses E2 because the single digit error occurs at the second digit, right? Yes, mod 4 for both sides, yes. So what we did is actually just apply that formula on the correct code and incorrect code to get the numbers, right? Okay. So what you want to find is that find the numbers A2 and E2, which makes this equation is true, right? Then you can simplify this equation. So for example, you can put, since we know that A1 and A1 are same and A3 and A3 part are same, so put negative 3A1, negative 9A3 on both sides. Then what you can get is 3A1 plus A2 plus 9A3 minus 3A1 minus 9A3 is equivalent to 3A1 plus E2 plus 9A3 minus 3A1 minus 9A3 mod 4. So both are in mod 4, you know, both are in mod 4. So, but in this case, again, as we did in the first one, this 3A1 is canceled out and this 9A3 are canceled out. Oh, yeah. Okay. Sorry. So these are canceled out. So all you have is A2 mod 4 is equal to E2 mod 4. It means that A2 minus E2 is multiple of 4. Okay, great. If you have any question on this simplification, good. So the condition is that A2 minus E2 is a multiple of 4. In that case, error will not be caught. So yeah, A2 minus E2 is a multiple of 4. And we know that the integer multiples of 4 between 1 and 9 are 4 and 8, right? So from here, you can also that it may be negative 4 and negative 8. And 0 can be counted because A2 is not the same as E2, right? So 0 cannot be occur. So if A2 is equal to, so let's check each cases when A2 minus E2 is 8. In that cases, first of all, then definitely A2 is 8 plus some E2 number, right? But E2 is from 0 to 9. Also, so if E2 is 0, then A2 is 8. If E2 is 1, then A2 is 9. If E2 is 2, then A2 is 10, but 10 is not allowed, right? Because A2 is a single digit, but 10 is not allowed in this case. So E2 cannot be 2. So the only possible cases in the first one is A2 is 8, E2 is 0, or A2 is 9, E2 is 1. Does it make sense? Or do you have any question on here? Okay, yeah, so you're okay with this conclusion, right? Okay, so from here, we just figure out that when A2 minus E2 is multiple of 4, right? But instead of just drawing to a table that each of the cases, we know that integer multiples of 4 is 4 and 8, right? And also negative 4 and negative 8, because we can occur the negative cases. So from now, I just choose each cases. So what I want to do is I just figure out when such a 8, 4, or negative 8 or negative 4 occurs, right? So I just want to figure out when such a case is. When 1, 2, 3, or 4 occurs. And to check out on the first case, when if A2 minus E2 is equal to 8, then what I try to do is just figure out starts from the 0, right? So I just start from the 0 in E2, then I will determine possible A2 value. So when E2 is 0, A2 is 8, because E2 plus 8 should be A2. And when E2 is 1, then A2 is 9, because 8 plus 1 is 9. When E2 is 2, then A2 should be 10. But in that case, A2 is not single digit, right? But what we actually assume is that A2 is a single digit from 0 to 9, right? So that's why we cannot make the sense for E2 is equal to 2. And if E2 is 3 or 4 or 5, then it also make A2 as a not single digit, right? It doesn't make A2 as a single digit, so we cannot do such a cases. So all possible cases when A2 minus E2 is 8 is 8-0 or 9-1. Does it make sense, Edward? Yeah, great. And we can do the same thing for next case when A2 minus E2 is equal to 4. And actually in this case, it has a little bit more solutions. So in this case, A2 is 4 plus E2. So again, start with A2 is 0. So if, okay, give me a second. Oh. If E2 is 0, then put it 0 here. You can get A2 is 4, and 4 is single digits, so it's okay. If E2 is 1, then A2 is just 5. So again, A2 is just single digit, it's okay. If E2 is 2, then A2 is just 6. So again, A2 is single digit, so it's okay. If E2 is 3, then A2 is 3 plus 4 is 7, so it's okay. If E2 is 4, then A2 is 8. If E2 is 5, A2 is 5 plus 4 is 9. But if E2 is 6, in that case, again, A2 is 10, but 10 is not allowed, right? So E2 is 6 cases are not here. And if E2 is greater than 6, 7 or 8 or 9, then again, it makes A2 as a 2-digit numbers, but this is not allowed in the case. So all possible cases are here, right? So 0, 4, 1, 5, 2, 6, 3, 7, 4, 8, 5, 9. Does it make sense? So we have 2 more cases, right? When A2 minus A2 minus E2 is negative 4, but okay, question?
So the numbers used as A2 and E2
Mm-hmm.
have to be between 1 and 9.
Yes.
So why do you use 0 still?
Oh, because I just think about the cases because 0 is just a single digit number, right? So I just start from 0 because 0 is the most smallest number we can use, and just figure out what happens in the A2. And if such a thing, if 0 and, for example, in 0 and 4 give just the same check digit, or give just the multiple 4, then it is the cases when the error will be not halted. And then we can check about the E2 is 1. So basically why the reason I start with 0 is that I just want to start with checking all the possibility, right?
So if we were asked to use between 2 and 9,
Mm-hmm.
could you use 1?
Yeah, in case of 2 and 9, then we can use, you can use 1. Yeah. Yeah, as long as it's a single digit, yeah, that's okay. Yeah. Great. Yeah, so, but in case of number 3 and number 4, instead of doing this again, you can actually have a trick that you can just change the numbers between A2 and A0. So for example, in the case of this one, if you just put A2 as the 0, E2 as the 4, then what you can get is -4, right? Because what we did, so if you see this, then the difference between number 2 and number 3 is just sign, right? So if you just change two numbers from A2 to E2 and E2 to A2, then you can get the same number with different signs, right? So in this case, you can just get A2 is 1, 2, 3, 4, 5, and E2 is 4, 5, 6, 7, 8, 9. So what I did is just transposition from 2, right? So it is just nothing but changing A1 with E2. And you can do the same thing on A2 minus E2 is equal to -8. So in this case, again, okay, you can just transposition between them. So here, if A2 is 0 and E2 is 8, this gives you 0 minus 8, which is -8. Or if A2 is 1, E2 is 9, then it also gives you -8. And this is the possible cases. Because if A2 is 2, then you cannot get -8 because E2 cannot be -10. E2 cannot be 10. So all possible cases when the check digit doesn't cut the error is 1, 2, 3, 4, 5, 6, 7, 8 times 2, 16 cases, right? So the conclusion is that the all possible cases when the check digit does not catch the error, the number of all possible cases when the check digit does not catch the error is 16. So, and from here, right? Okay. Does it make sense? Or do you have any question? Good. Okay, then let's deal with one more example. So let the check digit for 4-digit number is given by here. We have a little bit different, notion. Oh, it is the same, actually, same scheme from the 1.5. And determine that if this scheme will catch transposition error of the first and second digit, right? So in this case, instead of the error on the single digit, we have a transposition error on the first and second digits. So correct, if we assume the correct one is 8-1, 8-2, 8-3, 8-4, then we can assume the incorrect one is A2, A1, A3, A4, right? So the user just put A2 on the first position and A1 on the second position. This happens when you just type keyboard very fastly. So where the check digit of the correct code is just given by, formula. And the check digit for incorrect code is that since you've just put the A2 on the A1 position, so first one, A1 should be changed to A2. And second one, A2 should be changed to A1, then the all others are same, right? Does it make sense? So do you have any question? Is it good?
Wait, I have a question about the last problem. Wait,
Mhm.
how'd you get 16 again?
16 is just all cases of the all possible cases in the pairs, right? So here we have 1, 2, 3, 4, 5, 7, 8. 1, 2, 3, 3, 4, 5, 6, 7, 8. Yeah, okay, 8. So here, in the case of 1 and 2, we have 8 cases. And in case of 3 and 4, it is just nothing but transposition of the case 1 and 2. So we have another 8 cases. So that's why we have 16 cases.
Okay, and so the 0 is counted because 0 is like a special number, even though it's like only asking for in between 1 and 9?
Yeah, it is just in between 0 and 9. So 0 can be the number. So, that's your question. Okay.
Do you see where I'm like getting the 1 through 9 part?
Yes, so in the digit, yeah, so you can see the A1 and E1 both are from 0 to 9, not the 1 to 9.
Okay, so is that just a typo or?
Where do you see it?
Like a little bit up. Like if you scroll up a little bit, see where you like wrote 9 in the blank? That statement says, what are the integer multiples of 9 between 1 and 9? Is that supposed to be 0 and 9?
So this is not a typo, but it is actually about the when A1 minus E1 is a multiple of 9. Because so what it means that A1 minus E1 cannot be 0. But A1 can be 0 or E1 can be 0.
Oh,
but
okay.
Just when happen, but they cannot be same.
Okay, thank you.
Okay, thank you. Thank you for clarification. Okay. Okay, good. Okay. Okay, so let's get back to the example 1.6. So do you have any question on getting this check digit? Is it good? So what I did is, since we just had error on transpositioning A2 and A1, so I just put A2 on the A1, originally A1 position, and I just put A2 on A1 on the originally A2 positions, right? So that's why I get this check digit. And again, we can just simplify this one. So this the error will not cut if the check are the same, if 3A1 plus A2 plus 9A3 minus 3A2 plus A1 plus 9A3 is your multiple of 4, right? And if you just cancel out those things, three A2. Then you can actually cancel out this 3A1 part. Sorry, not 3A1 part. So you can cancel out this 9A3 part here. And 3A1 minus 3A1 is 2A1. And A2 minus 3A2 is minus 2A2. So we have mod 4. Then it is 2 times A1 minus A2 is mod 4, right? I just put out 2 from the equation. question? Here we just started with mode 4, right? So what we did is just from 3A1 minus A1, we get 2A1, right? But also A2 minus 3A2, we get 2A2, but we didn't touch anything on the mode 4, right? So that's why we still have mode 4. Okay. And next part is actually, yeah, what Grace actually pointed. So here, what we can say is that actually it is a little bit complicated. This number is the same as A1 minus A2 mod 2 because, yeah, that's what I didn't introduce in the last time. You can actually divide this number and this number at the same time, right? So I just divide by 2 in here and here. Then this one is 2 and this 2 is just deleted. So you can get this number. Does it make sense? Or is it good? So here divided by 2, you can get A1 minus A2 is a multiple of 2, right? So this is because if A1 minus A2 is just multiple of 2, then by multiplying 2, you can get it is actually multiple of 4. So A1 minus A2 is just, yeah, the remainder is the same as when you divide it by 2, right? Okay, so great. So here, and integer multiples of 2 between 1 and 9 is 2, 4, 6, 8, and 10 cannot be here. So only 2, 4, 6, 8 are possible. And again, minus 2, minus 4, minus 6, minus 8 are also possible. So you can get those pairs by thinking that A1 minus A2 is 2, A1 minus A2 is 4, A1 minus A2 is 6, A1 minus A2 is 8. So here, first case is the same as A1 is equal to A2 plus 2. So here, yeah, I just start with A2 again. So if A2 is equal to 0, then A1 is 2. If A2 is equal to 1, then A1 is equal to 3, 2, it is 4, 3, 5, 4, 6, 5, 7, 6, 8, 7, 9. And you cannot get 8 because 8 gives you 10 on the A2, A1, but 10 is not allowed. So these 8 numbers, 8 cases can happen in that when A1 minus A2 is just 2. And in the next case, A1 is equal to A2 plus 4. So when A2 is 0, A1 is 4, A2 is 1, A1 is 5, A2 is 2, A1 is 6, A2 is 3, A1 is 7, A2 is 4, A1 is 8, A2 is 5, A1 is 5 plus 4 is 9, A2 is 6, A1 is 10, but 10 is not allowed, so A2 cannot be 6, so you can stop it here. So it has 6 cases. And do the same thing on here. A2 plus 6. And in this case, again, start with A2 is 0, A1 is 6, A2 is 1, A1 is 7, A2 is 2, A1 is 8, A2 is 3, A1 is 9, A2 is 4, A1 is 10, but 10 is not a rod, so this case is not a rod. So A6, 4 cases. And here, maybe you notice that from A6, 4, it should be 2, but let's check it. So A2 is 0, A1 is 8, A2 is 1, A1 is 9, A2 is 2, A1 is 10, but 10 is not allowed, so delete these cases. So all cases from here is 2 cases. And again, you know, the negative cases are the same one, but different position, right? So A1 minus A2 minus 2 is the same, but different positions. So it is 2, 0, 3, 1, 4. Okay, question? Where I start 5?
You're going to do 5 right now.
Yes.
Is 5, 6, 7, and 8 just the exact opposite?
Yeah, exact opposite. Yes.
But we're not going to count them.
Yes. So we need to count it, but we don't want to count it again like using that procedure, right? Because it is time consuming. So instead of just counting it, just transposition of your answer. So 40 cases. Yes. Yeah, it's doubled. Yes, because we need to check about the negative cases also happen, right? Yeah. Great. Good question. Mm-hmm. Yes. So yeah, when you have the cases for number 1, then actually the number is same as the other case in number 5. Yes, you can just do the first one for the positive cases, then just double it, then start. Yeah, that's good. That's good. That's good procedure, right? So what Grace and Abud asked is that in the case of 5, 6, 7, 8, and this is nothing but just transposition of previous cases because they are the same, but all these signs are different, right? So just double it and start, right? So from here, what you have is 20 cases. So you can again have 20 cases from, 5, 6, 7, 8, but which is just nothing but transposition of the numbers, right? So you have 40 cases in the total. Does it make sense? So, good. Okay. Great. Oh. Okay, got it. Mm-hmm. Okay, let's do the example 1.7. So let the check digit A4 here 4A1 plus 7A2 plus 2A3 mod 10. And will this catch all single digit error in the third digit? So here our correct code is A1, A2, A3, A4. And incorrect code is A1, A2, E3, A4. So check digit for correct code is 4A1 plus 7A2 plus 2A3 mod 10. And check digit for incorrect code is 4A1 plus 7A2 plus 2E3 or 10. And the error will not be caught if check digits are the same, and it is the same when the difference between those numbers are multiple of 10, right? Each multiple of 10. Then again, you can just cancel out this 4A1 and cancel out this 7A2 part. So by simplification, cancel out 4A1 and 7A2 to get 2A3 minus 2E3 is multiple of 10. But this is the same as 2 times A3 minus E3 is multiple of 10. But this is the same as, by dividing 2 for both equation and in the multiple side, you can get A3 minus E3 is multiple of 5. Does it make sense? Or do you have any question before going further? Good. Okay, great. So the error will not be caught if A3 minus E3 is a multiple of 5. And we know the integer multiples of 5. Yeah. Sorry, it should be. I just missed off. Between 1 and 9 are 5, right? And also we care about the -5 cases. So we know that A3 minus E3 is 5. It happens when A3 is E3 plus 5. So if E3 is 0, A3 is 5, E3 is 1, A3 is 6, 2, 7, 3, 8, 4, 9, 5, 10, but 10 is not allowed. So just delete the 5, 10 cases to have 5 cases. And again, A3 minus E3 is equal to -5 is nothing but transposition of this, all right? So here, what we have is 5, 0, 1, 6, 2, 7, 3, 8, and 9, 4. Oh, sorry, 5, 0, 6, 1. Yeah, transposition everything. So 6, 1, 7, 2, 8, 3, 9, 4. Again, so it gives us 5 cases. So total 10 cases. Okay. So error will not be caught in those 10 cases when error is from 0 to 5 or 1 to 6 or 2 to 7 or something like that, right? Great. Do you have any question? Good. Yeah, because of time, I think that I just stop here. So I will just do more on the next time because it is the most difficult thing. And also I will extend homework due date for the, other ones. So, okay, thank you for hearing. And if you have any question, please let me know. Okay, do you have any question on Zoom? Then I will close the session. Thank you for listening and see you in the Thursday.